is about limit theorem. So theorem 1, limit of a constant. The limit of a constant is itself. Then limit a where x approaching c is equals to a. Example, limit 3 which x approaches 2 is equal to 3. Example number 2, limit 5,000 which is x approaches 0 is 5,000. So theorem 2, limit of an identity function. The limit of a function's f of x is equals to x as x approaches c is equals to c. That is, limit x where x approaches c is equal to c. Examples number 1. Example number 1. Limit x as x approaches 0 is equals to 0. Example number 2. Limit x as x approaches 3 over 4 is equal to 3 over 4. Theorem 3. Limit of the sum and difference of two functions. This states that the limit of the sum of difference of two functions is simply the sum or difference of the limits of the individual functions. Then, limit f of x as x approaches c is equals to L. Then, limit g of x as x approaches c is equals to m. Then, limit times the quantity of f of x plus a negative g of x as x approaches c is equals to L plus minus m. Example, if limit f of x as x approaches c is equals to 5 and limit g of x as x approaches c is 3, then limit the quantity of f of x plus g of x as x approaches c is equals to 5 plus 3, which is 8. Then limit the quantity of f of x minus g of x as x approaches c is equals to 5 minus 3. So theorem 4, limit of a linear function. The limit of a linear function f of x is equal to mx plus b, where m and b are any constant. We can say that limit mx plus b as x approaches c is equal to mc plus b. Example, limit 2x plus 3 as x approaches 3 is equal to 2 times the quantity of 3 plus 3. Just substitute the value of x, then 6 plus 3 is equals to 9. So number 2, limit 3x minus 2 as x approaches 0 is equals to 3 times 0 minus 2. Just substitute the value of x, then. So theorem 5, limit of the product and quotient of two functions. This states that the limit of the product or quotient of function is simply the product or quotient of the limit of the individual functions. In symbols, if limit f of x is equals to L as x approaches c and limit g of x is equals to m as x approaches c, then limit f of x times g of x is equals to L times m as x approaches c, and limit f of x over g of x is equals to L over m as x approaches c, such that limit of the denominator should not be equal to 0. In case where the denominator is 0, the limit does not exist. Example, if limit f of x is equal to 6 as x approaches c and limit g of x is equals to 1 over 3 as x approaches c, then limit f of x times g of x is equal to 6 times 1/3 is equals to 2. That is limit of product. Next is limit f of x over g of x as x approaches c is equals to 6 divide 1/3 is equal to 6 times 3 over 1 is equal to 18. That is limit of quotient. So theorem 6, limit of nth power of a function. This states that the limit of functions with power n where n is any integer, is simply the limit of the function raised to the power n. In symbols, limit f of x to the power of n is equals to L to the power of n as x approaches c. Example. Example number 1 is limit the quantity of 3x minus 3 squared as x approaches negative 2 is the quantity of 3 times negative 2 minus 3 squared, then the quantity of minus x minus 3 squared, then minus 9 squared is equals to 81. So example number 2, limit 3x minus 3 to the power of negative 2 as x approaches 2 is equals to the quantity of 3 times negative 2 minus 3 to the power of negative 2, then 5 to the power of negative 2, then 1 over 5 squared is equals to 1 over 25. So next is Theorem 7, limit of the nth root of a function. They state that the limit of the nth root of a function is simply the nth root of the limit of the function, provided that if n is even, the value inside the radical sign should be greater than 0. In symbols, limit the n root of f of x is equals to n root of L, where as x approaches c, where L is greater than 0 if n is even. Example, limit fourth root of 3x plus 7 as x approaches 3 is equals to the fourth root of 3 times 3 plus 7. Substitute the value of x, then the fourth root of 9 plus 7, then the fourth root of 16, and the answer is 2. Example number 2 is limit square root of 3x minus 2 as x approaches to negative 3, then the square root of 3 times negative 3 minus 2, substitute the value of x, then the answer is the square root of negative 11. Notice that the index is even and the radicand is negative. It is therefore impossible to solve for the limit of this function since the square root of a negative number is imaginary. So that is why b and e does not exist. That would be all. Thank you and God bless everyone.